All right, finally, we get to do some synthesis, guys. Are you excited? The synthesis strategy we're gonna go over. There are three of them. Okay, in this chapter, number one, we got functional group interconversion. You convert one functional group to another, and I'll walk you through it. Okay. Next one, we got changing the oxidation state. This one, oxidation reduction. I mean, you some oxidizing agent or reducing agent might come to your mind. Okay, those we're gonna use those. And the last one, we have the extension of carbon chain. Okay, let's get to the first one. How's that? All right, let's do the first one. So this one, changing functional groups. Okay, and I think that you guys know. So you have seen this carboxylic acid derivatives, and these are the relative reactivity. Okay, so I want you to focus your eyes on the acid chloride or bromide up here. Okay, this is the most reactive molecule, the most reactive functional group in this chapter. Once you have an acid chloride, you can go anywhere. Let's take a look at the logic behind it. Okay. All right, let's do this. Let's say you have an acid chloride and then you want to convert to an acid anhydride. What do you have to add? Here's how you should think about it. Okay. So this is an acid chloride. When chlorine leaves, you have this group right there. This is acyl group. Okay. Or an acyl group. If you want an acid anhydride, look at the structure of acid anhydride. You already have this acyl group right there, right there. Okay. All you have to do is adding this group right there. If you follow me, okay, you just need to add this group onto an acid chloride. What is this group? What is the synthetic equivalent of this group? Well, carboxylate. You know, whatever you want to go to, just add what you want to get. All right, so you add carboxylate group, get to an acid anhydride. Let's try another one. Think with me, okay? So try to think with me. Start with an acid chloride, okay, and then I want to synthesize, let's say, an ester. Look at that. This part is from an acid chloride, right? This part right here. All you have to add is this guy, the alkoxide. What is the equivalent of an alkoxide? Well, you should think about an alcohol. Don't forget to add pyridine. Pyridine used to trap the hydrochloric acid. Okay. Let me ask you one more time. Okay, start with an acid chloride, and I want to make an amide. Okay, so an amide, this part is already come from an acid chloride. All you have to do is add an H2 group. Okay, what is the synthetic equivalent of an H2 group? Well, you probably think maybe ammonia or some type of amines. Okay, it depends on the structure of amide that you want to get. Okay, one more acid chloride to let's say carboxylic acid. Okay, all you have to do is just this part, the hydroxide, right? The OH. What is the synthetic equivalent of the OH? Well, you probably think it might be sodium hydroxide or maybe water. We call this hydrolysis, base hydrolysis or acidic hydrolysis. Okay, and the only way to make an acid chloride is from carboxylic acid by adding thionyl chloride or the oxalyl chloride. Okay, so I want you to think about this, all this functional group and their relative reactivity as a waterfall. If you are at the top of the waterfall, you can go down anywhere, easily. Okay, only way to get to the top is you have the carboxylic acid and take an elevator, thionyl chloride or oxalyl chloride, go all the way to the top, and then from down here you can go anywhere. Okay. One more thing, note that I put nitrile down here, but it doesn't mean that this guy is unreactive or very low reactivity. I just don't have anywhere to put them into this relative reactivity chart. Okay, nitrile is actually reactive. You can do reaction on it, and probably more reactive than the amide. Amide adding thionyl chloride is going to be really reactive actually. Okay. Anyway, so that's the functional group interconversion. Let's try to do some practice together. Okay. All right. Let's take a look at the next video.